Hi and welcome to this update from the Paul Wurth Chair here at the University of Luxembourg. We have a special invited guest here with us today, Professor Matthew Hill from Monash University in Australia. I'm going to ask him a few questions and we're going to have a bit of an informal discussion. But basically, Matt and I have been friends and collaborated since many years, and it's really wonderful to have him here as a scientific visitor in our group today, but also for us to catch up on some of our past collaborations. So first, Matt, what brings you to Europe? Because you're not here just visiting University of Luxembourg.
No, it's a long way to come from Australia to visit, so making a few stops. Had some other technical meetings in some other conferences. I was in Spain for a day or two, then over to Greece, and now up to Luxembourg. A few hop, step and jump over here in Europe.
Very good. So you've seen a bit of Europe and you've seen a few different climatic conditions as well. So in Luxembourg, it's autumn now. It's rather cold, wet and rainy. But you had some good weather as well, right?
Yes, the Greek islands tend to be pretty warm and sunny when you're down that way, so got a bit of sun, and then up here for more temperate conditions. Yeah.
That's a nice way to put it. So more to our background, you and I have worked in similar topics and in similar locations since a long time. We tried to work it out earlier today, maybe 2009 or so was the start where we began to collaborate. And at that time I worked at Monash University, and I guess you were entirely at CSIRO.
Yep, that's right.
But can you tell us a bit about how your career has well, firstly a bit on the collaboration, you know, the topics that we worked on in the past.
Yeah, well, it's at least 16 or 17 years that we've worked together, and I think we've always been interested in porous materials, polymers, metal organic frameworks, anything with holes in it we've been interested in. And we've done a whole series of things on separating especially gases from one another. So we've done a lot of work together on separating CO2 from streams, and also some work in separating hydrogen from other things like nitrogen and methane, which is a forerunner to what you're doing here.
Super.
Today.
Yeah, and actually some of our collaborations even extended a bit as well. So when I moved to Imperial College, we had two more students together, and there we went on from gases to chiral molecules, which is a very, very ambitious and difficult separation. But some very successful projects and publications, and two graduated students there.
We had a really nice paper together, I think it was called Upcycling a Plastic Cup, where we took a polystyrene cup and pulled it apart and reconstituted the starting materials.
That's right, yeah.
Really
and
nice
those two students, Ben and Maureen, have both gone on to very interesting careers here in Europe. And earlier today in our group meeting, you talked about some of the successful careers of our earlier joint PhD students. So I've very much appreciated our scientific collaboration.
Yeah, it's been a good match.
And our friendship
long
over
may
many.
It continue.
Long may it continue. Yeah. So I mean, we are focused a lot now on hydrogen.
Yeah.
And you presented earlier today some really fascinating work on lithium sulfur batteries, and especially the separator, the membrane. So can you give us a bit of a general short summary of what you're doing in this area and why is it important?
Well, I guess in general with batteries, the separator is in every single battery, and it's basically a bystander at the moment. It's just there to keep the two sides of the battery apart from one another, stop a short circuit. And given all what we learnt about making molecules move through a membrane, we realised that if you made it functional, you could do things like make the battery last longer, make it be able to be charged up more quickly, make it safer. And so we've had a good 10 years or so of working on these areas, because lithium sulfur batteries are very interesting. They're at least half the price to make compared to a lithium ion battery, at least double the performance, and they don't rely on critical minerals to produce them. So it's really a challenge for us as material scientists and engineers to get them working a bit better, and then we'll see them used very widely.
Super. Yeah, and one fascinating thing that I heard earlier today was that you're now taking some of your research findings and, together with colleagues, commercialising them. So can you share a little bit of that journey of research commercialisation?
Yeah, it's a whole new world, commercialising, a different set of criteria, and I think for those of us who are researchers at heart, this is important because it just helps you to ask better questions about your research. What you think is the most important thing to work on might be quite different once you start to engage with the industry, and commercialising your own technology is just that to another level. And so what we're doing now is we're setting up a little manufacturing facility to make more of our batteries, optimize them, make them bigger, and then they can be certified and warranted by independent testing authorities to say that it does what it says, and that then allows us to work with the users of the batteries and to test them.
Super. And I mean, since many, many years we've worked in partnership with industry, but what would you say is, like you said it very quickly there, it goes a little bit further than just working with industry, because you're really trying to create your own company together with your colleagues and develop products that you can, get people to adopt them, and then I guess sell the company or go into a larger scale of manufacturing. Do you have a vision for where it's going to go?
Yeah, there's a lot more to think about with that, and there's a lot more personal responsibility. So the address of the company is my house. So if something goes wrong,
I think Steve Jobs started that way too. But
we'll see about that. But broadly speaking, we don't think that we're going to go into building a gigafactory and making these. We've got some partners who we're speaking to, and I think the real success for us will be to make enough to get them certified, have the formulation, and we can then partner. We've already spoken to the manufacturers who have said, if you can do that, we'll make a lot of your cells. And so then we can focus on talking to the users and working on the engineering processes and continuing to make the battery even better.
Super. So let's turn a bit to the core business of universities, which is teaching and research and engagement with society. You're still teaching, and you're now leading a whole department in the Faculty of Engineering at Monash University. And to give our listeners something of a sense of scale, we talked earlier about how big is the University of Luxembourg, where we have maybe 3,500 bachelor students, 2,500 master students, and 1,000 PhD students. Can you give us a quick sense of the scale of a big public university in Australia like Monash University?
Well, Monash is the biggest university in Australia. It's got about 75,000 students and about 25,000 staff. In the Faculty of Engineering, we have around about 10,000 students that are either undergraduate or masters, and then about another 2,000 PhD students as well. We have only, I say only, 140 academic staff, which seems like quite a small number when you consider the number of students. But yeah, it's a big business, and so scalability or working at scale is very different to working just in a small research group.
Yeah. But speaking of research group, you're still very, very active with your own research group, and you have really fascinating collaborators. Speaking of some of the people like Marnik Majumdar, Benny Freeman, can you give us a little picture of what your group is like and your core collaborators, and really what's the research passion that keeps you going every day on research?
Yeah, so the big thing, we have a real community that you're a part of when you were with us in membrane science and separations, and I think that it was a big deal for Monash when Benny Freeman decided to come half-time, and if you're not familiar, he's probably the best membrane scientist in the world. And Benny said, what I think we need to do is to have a pilot facility. So we were busy making an amazing material, maybe the size of a coin, testing its properties, writing a really good paper, and then moving on. And what we've done in the last, we just finished commissioning the equipment about 3 months ago, is to have the ability to make a membrane module, either for a gas separation or a liquid separation process. And that module is sort of the minimum viable unit for an industry partner.
Industry to test it, I guess, yeah.
And so we're kind of testing our own hype in a way now. So the research that we're doing is all about trying to make it as real as we possibly can, and that's been Benny's guidance as someone who's worked his whole career in this area. So we're really dipping the toe in, but it's a different set of things to learn now. So for us, when we were working, we're making a little vial of a material, and that's great, and we can test it. Now it's, well, we need to make tens of square meters of it, and so there's a series of challenges that weren't evident before become evident now, and you have to think about those. So that's a good way to keep learning all the time too.
Super. When I reflect on my research sort of trajectory or career over the last 16, 17, even almost 20 years since, because we both finished our PhDs, I think, in 2006.
We did.
Same year. So it's coming up to 20 years post-PhD. And I've gone to gas separation membranes, liquid separations, porous materials, photoresponsive porous materials, hydrogen separation materials, but really quite a consistent focus on the materials.
Yeah.
But really there is like different applications, different focus, different scale. What do you take from your journey that you would give as advice to a young academic starting out now, 20 years, back on the journey from us? Or what advice would you go back and give to Matt 20 years ago?
To myself going back, yes. Well, that's a very challenging question, I guess. And some of the things that come up when we're talking in groups are about, recognising what is the key experiment that I should do early on to know, am I on the right track? And that I should expect to be wrong most of the time. And when you're starting out, that's a very hard thing to learn. And as you go along, you get this privilege of you're not so worried about success and failure anymore, and it's more about doing something impactful along the way. And so I think for people starting out, it's that question of what do I want to be known for? What's the thing that I truly want to do? And the point of research is everyone can pick something different. And once you pick what that is, you can work with other people who are good or interested at the other things and work in teams. But there is a reality that I think it's harder today for people to get started than it previously was.
Very true.
And there is a lot of need that you have to focus on getting yourself that career going first. So I try to support those people too, because it's hard.
And what about forming teams, establishing collaborations, mentoring networks? How important is it for young career academics or scientists now to find the right people to work with on the right projects in the right setting?
Yeah, I guess that's it might be easier these days, or we're more connected. But one thing that comes along is I think the person is almost the most important of those parameters. And if they're not working on the exact perfect topic, that's okay, because you're going to come up with things. In the department I head up now, probably one of the most exciting projects is one of our biologists. She's working with one of our metallurgy experts, and in our department they would be as far away.
They are very broadly separated topics, actually.
Exactly, but they came up with a 3D printed metal bone screw. So if you break your finger or something, you need a screw, and it's dissolvable, it's biodegradable. And so there's a lot of biology in there as to how fast does it dissolve, is it safe, does your body put bone where the screw was? And they just wrote a paper in Science on that about 3 months ago, because they really get on with each other.
Yeah.
And so they were easily able to talk this through, and it's many years of effort to do something like that. On paper, you would say, why are they working together? But actually, the personal getting on a low maintenance relationship's important, I think.
Yeah. So we've covered a lot of things in our discussions. We just had a nice lunch together here on the university campus, and we talked about AI. And I think there's tremendous opportunities for people to use AI tools to change the way they do their job more effectively, do it faster. But I very, very strongly believe in what you just said, that the right chemistry, the right connection in the people that you work with will never be replaced by tools or techniques or software, because those things might help. And like you said, the communication tools that we have now are different to what existed 20 years ago. But nothing will ever replace the fact that, in my opinion, good science is done by groups of people, very rarely by individuals. And the connections and the chemistry is more important than anything else, I would say. Access to the equipment, access to the right chemicals. If you don't have that good connection with people you get along with, that are complementary, actually having exactly the same interests and skill sets is probably not ideal.
No, you need to be sort of neighbours, and I think it becomes a lot less transactional. When I was starting, I'm the guy making materials, so I'm looking for someone to send them to that can test them for something. Yeah. And it's very transactional. I'll post it to you, you stick it in your machine, and then we'll write a paper.
Yeah.
But I don't think I did a project ever where that happened.
No.
It's always an iterative process.
Yeah.
It didn't do what we thought it would do. Why is that? Let's talk about it. And you need someone that you can easily work that out together. And those people, it's just finding that network. And as you get to our age, you kind of have that network and you know most people, and it's up to us to keep the doors open, keep looking to work with others as well.
Love to hear that. Yeah, not pull the ladder up, but actually to put the ladder down.
Correct.
And help bring people up onto the boat, join the party, and come along for the ride.
Exactly. And we don't have it all worked out either. We never did. So if people are getting started and they're uncertain, well, let's work together.
I'd love to hear that. I listen to a lot of podcasts, and one of the things that I often hear is closing out by saying, what's the positive, optimistic hope for the future? So you are still working in this amazing country, which is Australia, which has a lot of great inbuilt benefits or resources or potential, but it's going through some challenging phases as well. But you're also at a university, which is one of the places that delivers solutions for the future, talent, innovation, ideas, research, solutions. So what is your sort of take-home message that you would give to people? Say, look, there is hope for the future. This is what it is. What's your message?
Well, that's what's the meaning of life, right? Well, the answer is 42. We know that. I think it's an exciting time now where we can do bigger things, more teams, more impactful, and involve more different types of people. And something that's really interesting that's happening in Australia at the moment is we're looking at what is it that critical minerals truly means. Like most things, if you dig a hole in the ground in Australia, we have it in the ground, but it asks us questions like, what do we actually mean by sustainability? What does it truly mean to extract something from the ground, to recycle it, use it in a device and the like? So we're having some very interesting conversations with our colleagues who might be in Indigenous studies, who might be in social science, about what does this truly mean, and just reimagining what engineers actually work on. And so that's really interesting, just doing things in a different way and seeing it where it leads us to.
That is fantastic. Thank you for sharing that. I have so much hope for the future when I hear that as well, because when I studied engineering more than 20 years ago, the discipline has changed a lot in 20 years. It was very much get the stuff, build and deliver, and if there's impacts on the side, so what? But you had to deliver and you deliver it. But I'm really pleased to hear that way of thinking and working is changing and involving the First Nations peoples of Australia in that discussion and in that journey. That's wonderful. It gives me really a good, optimistic and hope for the future. Yeah,
it's really encouraging. Our students are leading this. They expect to know about sustainability from the beginning, and that's great. And I had a meeting the other day with a very large engineering company, and they said to me, we have a rule, we will not produce a waste stream.
Wow.
And when I
Zero
know
waste.
that every single molecule that comes out of a process, we use it for something else again.
Yep.
And I thought that is just an incredible way to think, because I know that company for decades would not have done that.
True.
But to make that change is just a new way of thinking.
Yeah, marvellous. Well, look, thank you so much for coming to visit us here at the University of Luxembourg, and we appreciate the input that you've had to our projects and the things we are doing in the lab, and I hope that we have another 20 years of collaboration and contact, and that should...
We haven't changed a bit, and we won't...
We look just as young as always.
Correct.
Correct answer. Well done. Thanks very much.
Thanks, Brad.